Hello everyone. In this session, we will learn about polar angle computation. In a two-dimensional figure, the Cartesian coordinates specify the location of a point in the plane. The coordinates are defined as x, y and the point as p. Another two-dimensional coordinate system is the polar coordinates. Instead of using the signed distances along the two coordinate axes, polar coordinates specifies the location of a point P in the plane by its distance r from the origin. An angle theta is made between the line segment from the origin to the P on the positive x-axis. The polar coordinates r, theta for a point P is illustrated below. As the distance r ranges from 0 to infinity and theta ranges from 0 to 2 pi, the point P specified by the polar coordinates r, theta covers every point in the plane. Adding 2 pi to theta brings us back to the same point. So if we allow theta to range over an interval larger than 2 pi, each point would have multiple polar coordinates. Hence, we typically restrict theta to be in the interval between 0 to 2 pi. However, even with that restriction, there still is some non-uniqueness of polar coordinates, where r equal to 0, the point P is at the origin independent of the value of theta. The picture shown here represents polar coordinates r and theta for different points. This figure that corresponds to theta equal to 0.32 radians maps to the points with x, y at 3, 1. The next one corresponds to theta equal to 0.79 radians and maps to the points with x, y at 3, 3. And the last one corresponds to theta equal to 0.59 radians at point x, y with 9, 6. Let's now discuss the conversion formulae. We can calculate the Cartesian coordinates of a point with the polar coordinates r, theta by forming the right triangle illustrated in the figure. The hypotenuse is the line segment from the origin to the point and its length is r. The projection of this line segment on the x-axis is the leg of the triangle adjacent to the angle theta, so x is equal to r cos theta, and the y component is determined by the other leg, and hence y equal to r sin theta. Our conversion formula is as shown here. Now let's deep dive into our Python implementation. We define the NumPy array for linear algebra representation of x, y coordinates. The coordinates are represented by point np.array at line number 7 and then printed out for verification. In the second code block, the points are extracted from the point np.array as x and y coordinates and then printed. In the final block, the polar angle and the radius are computed using the conversion formulae and then finally printed. Thanks for hearing and watching.